Hello again. Well, I've done another video. I haven't done one for a while, so I thought I'd do another video. This is to demonstrate some more memory tests you can do with this tester. There is a new version of software that I'm working on, and it's got a couple of extra features in it, which will be rolled out into the existing testers very soon. Now there's two commands I can do here. Now what I've done is I've got my tester, it's on the LCD screen, and there's a reason for that, because in the background you can see I've got a nice blue and purple pattern, which happens to be the video output of the board I've connected up to. Now because the processor has been taken out, my pod's connected in, the board basically is generating video but it's not doing anything, and it's actually a Pengo board on this occasion. Now what I'm going to do here is I'm going to test the RAM chips on the Pengo board. Now I don't know where these RAM chips are located in the memory map, so I happen to have a command which will find that for me. So if I go into my main screen there, click that and type in map, what it will do is it will find the memory map for me. Now the default, if you don't put anything, just type map, it will do it in 1K steps. So every 1K it will check the memory to see if it's ROM or RAM, etc. Now if I put in, say, map 0800, which in hex is equivalent to 2K in decimal, it's going to go up in 2K blocks. So if I run that, you'll see the memory map will appear. Now you can do this anytime you like. It doesn't affect the address you set the tester to or anything. And as you can see here, all the addresses are in 2K blocks, and it tells me they're all ROM. If I scroll back up to the beginning, you see it goes right way through ROM. There's where I started, but then there's two bits here which start at 8000 to 87FF, and it's highlighted them in green as RAM, and 8800 to 8FF is RAM as well. If the RAM appears to be possibly faulty, it might highlight it in red and say faulty. Okay, so at the moment you can see there's two blocks of RAM which amounts to 4K in total. Tallies up because there's two 2K RAM chips on the Pengo board. Now these are VRAM, so these are getting used to generate the video, as you can see in the background. So if I want to test those, I would set the address to 8000, for example. Okay, write that, and you can see the tester will go to 8000. I then go back down to my information and I type in RAM test. And then you have to specify how many bytes you want to test. Because they're going to be 2K chips, I'm going to put in 0800, which effectively is 2K in decimal. I'll do enter, and it will say start address 8000, RAM block size 0800, it's testing the RAM, and in brackets it says 2048 bytes, which is 2K in decimal. And in the background, as you can see, there's like a sort of cursor thing flashing across the screen. Now that's happening because every time it checks an address in the RAM, it's writing in either 0, FF, AA or EE. And the reason it's picking or AA, sorry, my mistake, if it's doing these, it means it's checking all the bits for short bits, and all the bits can go to zeros, ones, etc. So it's done a full check. After it's done it, it puts the original value back in, so whatever's on the memory or in the on the screen is preserved. Okay, so as you can see, it's now doing the colour, and you get a little block appearing. You can see it going in the background, which indicates it's testing all that memory. Because it's VRAM, obviously the video display is using it as well. So you can see the tester is obviously testing the RAM in between the video display using it. And there you go, it's got finished it, and it says RAM test passed at the bottom in red. I don't know if I move it in a bit closer, you might see it's gone out of focus, but it's actually down the bottom there. So you can do that anytime you like. Again, it doesn't matter. So if I did RAM test again, for example, I don't have to change any addresses because the test is still set to 8000, and I'll do this time, I'll do 0400, which is 1K. So it's doing exactly the same again, but only doing 1K, which means it's only going to test half that chip for me effectively. As you can see, it's going through all that. It does take a little bit of time, but bear in mind, for say 1K of memory, it's doing effectively probably about 4 to 5 read-write cycles per address. So you know, it's not too bad. This indicator over here is high and low, which indicates it's reading and writing. It's gone back down there now. So when it's high and low like it was indicating it was input output. So that's it, reading and writing data the whole time. RAM test passed again. Now I'm going to demonstrate what happens when you turn the power off, which will indicate a fault condition. So I'll do RAM test. This just proves this board is actually doing this and the test is doing it, in case you think I've frigged this, right? So let's just have a look at this. We'll do RAM test 0800. Away it goes again. As you can see, the cursor in the background. It's not so obvious on this background because it's obviously all pink and purples, or blues and purples I should say. You can see it going along there. Now if I turn the power off to the board, 3, 2, 1, failed straight away on test AA, failed AA test at address 81B5. AA means it's trying to write data AA pattern to the RAM and read back, and it failed. Obviously there's no power. So you can see it failed straight away, so it will pick that up. And obviously if the RAM is faulty, it will fail as well, and it will indicate the address it fails at and what data pattern it's trying to write to. Now the next video I'm going to do will show you more of what we can do with the VRAM, such as clearing it and putting characters up and stuff like that. Thanks so much again. Alright.